So, question 16. We've got a curve shown below and its equation, and it looks pretty circular. Anyway, let's see, what have we got to do? Calculate the area, correct to quite accurate here, the fourth decimal place, of the region that forms the interior of this curve. Right. So let's have a look here. I've given myself a copy of the relationship for the curve down here. Before we pile into the calculator, it's only 3 marks, so we got to get a shuffle on. But anyway, I've said let f of x. So out of this one, if we basically square root both sides here, then we've got y minus 1 is the square root of sine of x pi x on 2. So then that means that y is going to be 1 plus or minus f of x if we call this bit f of x. And so then the integral, because obviously on a question like this, the key mark is going to be writing down the correct integral, then we want to integrate now. Because it's plus or minus the square root of this bit, so obviously 1 plus f of x is going to be the top part and 1 minus f of x will be the bottom part. So we want 1 plus f of x subtracted from 1 minus f of x when we do our integral. So here I go. The area is the integral from 0 to 2 of 1 plus f of x minus 1 minus f of x. And of course, when you look at this, the 1's cancel out and we end up with 2f of x. So that's going to be a little bit quicker than typing in some massive integral on this one. Let's grab our calculator and have a go at that. So here we go. We'll store f of x, I think, first. So here we go. We'll get the keyboard up. We get the square root. We've got sine of a fraction. Upstairs is pi x and downstairs is 2. And then we need to just tap into there, close my brackets because I'm going to store this as f. Tap outside the function and store this as down here as f. Okay, and that's my f sorted out. Right, now we're good to go. Back up to Math 2, get the integral template, and I want 2f, which I could steal the f from up here and just drag it down to there with respect to x from 0 to 2. Now, this one doesn't take too long, but it's still not in an insignificant amount of time. But anyway, here we go. I'm in standard mode, but we actually didn't get an exact answer to this. So it's 3.051. So there's the first 3. And then part B says, using the answer to part A, determine whether this curve is a circle. Explain your answer. Well, I'm looking at it now. The radius is 1, so if this was a circle, then it's pi r squared. The radius is 1, so we should end up with pi. So that's what we've said here, and because they're not the same, then hence the curve is not a circle.